a 4-year experienced guy is getting a so product based company, they pay good. And even here in embedded also we do have bonds, and there is a fine amount. If you are breaking the bond, you need to bond. So at least 2 to 3 years bond you will have in embedded as well.
In the starting years, the increments are very good. Usually it's minimum 40 to 50. Some companies even 100%. In product company, it is 12 LPA. Usually, sometimes, rarely it is 7.
So hello everyone, today in this video we will be comparing embedded versus VLSI, and here is my friend Rohit. So first let me introduce myself first, then I'll introduce Rohit. So my name is Mohammed Mudassir, and from 1 year I'm working in the field of embedded systems. So Rohit, hi Rohit, can you
Oh,
introduce?
hi guys, I'm Rohit. I am a formal verification engineer in VLSI field, and my experience is also little more than a year.
Yeah, okay. So let me start. We'll start a debate and we'll compare one by one, and we give points on embedded and VLSA, and at the end let's compare which the main events are like that. Okay, so about embedded, first let me talk about embedded. What is, let's start with the VLSI first. I think then on top of that I can talk about embedded. Yeah, Rohit.
Okay. Okay. VLSI, as it says, it improves with technology, very large scale integration. So here the job market is very big and lot of job roles. Primarily, the most famous one is design verification, where you verify the RTL coded by the designer. So we have different roles, and they pay very well and all. So yeah, it's a very quite booming industry, and since the semiconductor is in boom, even Indian government and all over the world is making a lot of progress in this field particularly.
Yeah, okay. Can you tell me what is it like? Is it the hardware design, or what do you do in VLSI?
Okay, I am particularly a formal verification engineer. Let me tell about verification. So there are stages. VLSI's end goal is we get a silicon chip.
Okay.
So before, when the VLSI was started back in the 90s, at that time they were physically making the circuits. So eventually they got bigger and bigger. Now the circuits contain billions of transistors, which can't be manually like drawn or made as a circuit like how we do in our colleges. So now first step we write the RTL coding. RTL is like a digital description, the coded description of the whole design. Then we verify that RTL. Then there is a synthesis tool which will convert the RTL to the gates. So this RTL to gate conversion happens automated. Like machine does it, tool does it. So then there is a verification of the netlist. So netlist is the output which we get from the synthesis tool. So after the netlist, there are few more steps like floor planning, where you place each chip and all that. And finally, you do a tape out. So there is something called a GDS2 file, which you will send it to the foundry, like the Intel foundry or the TSMC foundry. They have their own machines. They will fabricate your chip, and you will get the chip shipped to you. This is the whole overall high-level process of the VLSI chip, silicon chip.
Yeah. So in the embedded, so as Rohit told, they are responsible to design the hardware. So later on, these people, they give us a data sheet. So data sheet which contains the specification of the registers and internal working and all those things. So on top of that, we are supposed to write the software, or what do you say, driver, or we are supposed to connect it to the bus and write drivers, maybe in C or C++. There are different kind of drivers like bare metal, or there are some Linux drivers as well. So these top level things we are supposed to do, and we are supposed to test it whether all the functionality is working properly or not. So and also, yeah, can you tell me about the what are the job roles or domains in Verilog?
Okay, in VLSI, if we take the job roles, there are usually 50 plus roles, like very niche roles. But usually, typically for freshers, the most famous one is design verification, as I told. Then designer, the RTL designer who will have to code the RTL. Then we have physical design who will do the part which is after synthesis, placement routing. Then this is the digital side. There are far more different roles also in digital side, like ASIC design engineer, FPGA design engineer. FPGA has its own set of different processes. And parallelly there is analog also. So we have analog design engineer. So digital will take care of processes like CPU, GPU, all those which are the digital devices. But the analog are all the sensors kind of devices. All the sensors and actuators are all analog. So we have analog design engineers and validation engineers in their own flow. Usually this analog part is for, usually they take people who are like MTech graduates because more knowledge which is required for that. But digital, it's more of it is coding. So BTech is fine, BTech is great, you can get something. So then once after this we have what do you say, EDA also. Like since we all do work on tools, like tools are very important. So EDA companies have their own separate things. So there the software or IT people have their chance. Like they can't, I won't say can't, but it's very difficult for them to be directly be part of this design process, the whole chip process. But the tools, they are made in Python usually. So they need like core software engineers for that. So they are the ones who make the tool and we are the ones who use the tool and
Yeah. Okay. In my domain, there are usually few different domains which we work, or different kind of projects which we work. One is the SystemC, and there is something called as ADAS, and there is like Linux device drivers. So in SystemC, which I am working right now, what we do is whenever the RTL or Verilog designers, they design some what do you say, peripheral or something, they give us the data sheet. So what we are supposed to do is we create a virtual model of the peripheral. So then the peripheral, we connect it to a virtual processor. We do not have an actual processor like ARM or RISC-V. So we have something called as a virtual processor. It is just a C++ program which will simulate the instructions as it is like a real processor. So we connect this peripheral to this processor, virtual processor. Then we can boot Linux on it, or without Linux also we can directly write a C program, then convert it to assembly level code, and then put it on the processor and run it. So what we usually do, we boot up the Linux on the processor, then we write a C program, compile it, and in that C program we have this offsets of every register and their respective bit fields and everything. So we try to read or write into the registers, and we test the functionality of the peripheral. So this is our task. We create this virtual model in SystemC. And ADAS is related to the testing of the virtual, automatic car driving, like Tesla and all this. So we do create a virtual scenario. We have our own, we have some tools which does the simulation of the car moving forward, and we add some obstacles, might be deer or some other cars. So we see how our system performs. And so this is about the ADAS. Then the Linux drivers and all, we write a Linux driver for the peripherals which is designed by the RTL guys. So this is about my embedded domain. So let us start with a comparison of one by one. Rohit. Yeah, hi Rohit. So let us start with our first comparison point, which is the entry barrier. So in entry barrier, I would say in embedded domain. So if a fresher wants to enter, it's little easy for him because we do hire freshers. We do hire freshers in majorly service-based companies. So they need to know like C, C++ programming, a little bit of digital electronics, and maybe a little bit of computer organization, computer architecture. So and some different peripherals like UART, I2C, SPI. So these things, if they are preparing, it is they will be getting hired as a fresher. So what do you say about you in VLSI?
Okay, yeah. In VLSI, I mean, entry barrier is not so easy. Okay, it is difficult. Usually,
Why do
the
you
only
say?
way you can directly get into VLSI,
Why
you
do
can
you say
directly
so?
Yeah,
get
why
into
do you say
VLSI
so?
is yeah, okay. Because the only way you can directly get into VLSI is as an intern at a product company. Because usually service companies don't offer an internship. This is what you can do from college directly, and usually those companies take internships from IITs colleges. The other way is to do MTech,
Mm-hmm.
and the third and most people do it is join a coaching institute for somewhere around 6 months, where they teach you
Mm-hmm.
all the like required things for a fresher, and your chances of getting into the field increases.
Mm-hmm. Yeah. Okay. So the fresher cannot get in directly. He should at least go into some training institute for 2 to 3 months and learn it, and then get into VLSI
Ye-
based domains. Yeah.
Yes,
So
correct. For
here I.
tier 3 college student, this is the
Mhm.
case.
So here I think we can give a point for embedded. So next thing is the learning curve. So in learning curve in embedded, I would say if some fresher is knowing C or C++, that is the minimum thing which we expect the fresher to be knowing. If he is knowing basic programming and little bit of computer organization, computer architecture, and digital electronics, these concepts are sufficient enough for him. So learning curve, I would say it is little easy. Yeah, in VLSI.
Okay, in VLSI, the minimum requirements are fundamentally digital electronics, then computer architecture, then Verilog.
Mm-hmm.
This was a case, this was sufficient if we were joining 3 4 years back. But now the bar is raised
Mm-hmm.
very high. Like they ask for system Verilog, UVM protocols like basic AMBA protocols, and even scripting,
Mm-hmm.
Python also they ask. So all
Mm-hmm.
this without going to a training institute becomes very difficult to learn.
Mm-hmm.
So
Mm-hmm.
these are the
So
very fundamental things.
So we can give a point to embedded in this case. So next is our programming language and debugging support. So debugging, how difficult is it? Programming languages, in my case, we usually do with the C, C++ is sufficient enough for us. We They also need to little bit work with the Linux device drivers, bare metal programming. In this case, we have a many different debugging tools that could be GDB. We can directly, what do you say, print and get the result. See, if suppose you are writing into some register, you can read back and just directly print the values. And this will be helpful for you to understand. So if it is working or not, if your peripheral is working or not. In case of Verilog, it's little difficult. So Rohit, what do you say about it?
Complexity of work here, again, it depends on the field. If we say digital side Verilog, which is HDL or coding, there, since it's a concurrent language, not a sequential language, uh, so a lot of things are happening at a time. So you don't know if anything is happening, then you'll have to debug it to the root. It takes a lot of time. If you are in the analog side, then you need to be very good with all those equations and all, which we studied in analog devices subject. So that gets
Mm-hmm.
even more complex. So debugging is
Mm-hmm.
a complex thing. And also the on digital side, if I go, the waveforms are itself like very large. Like if some regression ones will go on for million cycles.
Yeah.
Debugging to the root, you get an error after 1,000 cycles, and debugging it, that error from the origin of the error was somewhere 1,000 cycles back. So tracing it back might get tedious lot of times.
Yeah.
In this case we can give a point for embedded. Yeah, so the next thing would be the AI, the role of AI, how ChatGPT or AI could replace embedded developers or VLSI developers in the future. How helpful is AI in embedded? So in my case, we can use ChatGPT or AI in order to write the bare minimal code. So suppose if you are programming some peripheral in maybe in SystemC, or maybe you are writing some driver for a peripheral. So this ChatGPT can give you very bare minimum coding and implementation of these things. But as you know, when we are working at some project or something, every data sheet, every peripheral will be completely different. It will have different specification, different registers, which will be responsible to do some feature, or every peripheral will have some additional features. So as we go on with the different versions like version 1, version 2, version 3, there will be additional features. So these features, the ChatGPT will not be trained in order to write this specific kind of code. So ChatGPT will help for a certain level, but at the end of the day we need an embedded developer in order to understand these things, in order to write this specific code. So ChatGPT might help. So what about you in Verilog?
Okay. In VLSI and AI can help you in reading the specifications. Before we start any project, there is an architecture. So they come up with the standard documents. So it has all the details of the project. So AI can help you summarize and memorize, or get you important things from the document, or even write some parts of simple code. As a fresher, we might get confused with some parts of simple codes. AI will help you in that, but doing the whole work on its own is still a far beyond. Even though the companies, EDA companies, are working on something called agentic AI, for example, Cadence and Synopsys, they are trying to combine all the AI tools of different processes and make an AI which can automatically do all the process starting to end on its own. But it will take yet a very long time, even according to the Cadence.
Yeah. So even I had tried Verilog once. So the AI is not capable of generating this Verilog code, and it is not able to debug or generate your code, proper code. So in this case, we could give a point for Verilog, VLSI. So
This AI is on like software programming also. So it is good with the sequential or Python based programs, but hardware where parallel things are going on, it gets very complex for AI.
Rohit. So next thing would be our job availability for this embedded and Verilog. So in case of embedded, there are good job openings for freshers. So for entry level, there are some good job openings in India, I would say. So in Verilog, how is it, Rohit?
Okay. I'd say service-based companies offer a lot of job openings in design verification, RTL design, analog design, physical design, DFT. Yeah, these are the common, but design verification is the most common. Yeah, to be at a startup, and the other way is to get an internship at a product company, which will eventually get converted to full time. That is the best you can.
I would say embedded has a little bit more jobs compared to VLSI, as what I have seen. So in this case, I think we can give a winning point for embedded. Yeah, and also in the product and service based, initially it is difficult to get into product based companies. Initially you get into service based, these service-based companies, they outsource you to product-based companies as our resource. So yeah. So what are all the top companies, product and service-based companies in your domain, Rohit?
Okay, product companies, we can say Qualcomm, Nvidia, Samsung, Meta, Google, AMD, all these CPU, GPU chip makers which over here in the market.
Let me start with the next point, which would be work-life balance. And yeah, what do you say about work-life balance in your domain
Yeah,
or your company?
work-life balance depends like widely in this sector. If you join company like Qualcomm, which makes different chip for every other mobile coming in the market, they have like 11, 12 projects every year. You're done. Like you have a lot of work, very lot of work. But if you join a company like Samsung, that depends on consumer electronics. Pressure is not that much. They do some projects. If you join companies like Intel, Nvidia, it's fine. They do one,
Mm-hmm.
two projects in a year. You have
Mm-hmm.
time. So it is like that.
Yeah.
Depends on the market. If you are on a data center kind making chip, then you have more leisure time. If you are on
Mm-hmm.
very consumer high market like mobile CPUs like Qualcomm, then you are in a
Yeah.
very bad state.
Similar here, similar here. Based on it, completely depends on the service-based or product-based companies. So work-life balance.
Yeah,
So.
service based will generally have less pressure.
Mm-hmm. Yeah, yeah. So in this case, we can give a win-win for both. What do you say about the work from home culture? How is work from home in your case?
That again depends on companies. There's companies like ARM where you can like go take 1 2 months work from home and like there are no fixed timings also. Like in a
Mm-hmm.
day you have to work for so many hours. The amount of work you have will be equivalent. It's both good and bad. Like
Mm-hmm.
basically, if you don't have work, you can chill. But when you have
Mm-hmm.
work, you have lot of work.
Mm-hmm.
Or if you're
So
going on,
what some people think is they think it's completely related to hardware. We need to stand there and work with the hardware. It's so it's not like completely like that. We usually work on the laptops only. So it completely depends on the project so which we are working. Some clients they are okay with taking you work from home, working from home. So some clients are like we need more security on whatever the project or work you're doing, so we need you to come to the office and use the office Wi-Fi, so it is more secure. So it completely depends on the client whether he wants work from home or not. So in both of our domains, there are few clients which allow work from home and few do not allow work from home. So that we can give it as a win-win for both of them. So what do you say about
yeah,
the innovation and creativity? Innovation and creativity and also research and development. So writing research papers and these things. So in embedded, what I would say it is little difficult because we are not creating some new or novel thing, or we are not writing some new algorithm or AI model or something like that. We basically just writing the driver code or embedded normal C program. So we cannot have much innovation or creativity to a certain extent. You can do creativity, you can connect different peripherals to a RISC-V processor, you can have some good working project, but you cannot have such a way like you can patent it or you can research papers are little difficult. So what do you say about you VLSI? Right?
okay, yeah. In VLSI, we have a lot of scope for innovation and R&D.
Mm-hmm.
If I take a simple example, if one guy makes an adder, a simple adder,
Mm-hmm.
uh, he can patent it if it was the first adder he made. And
Mm-hmm.
if another guy makes an adder, even he can patent it. But what is the difference? It all comes down to PPA, power performance area. Like if your adder is better in area, and that's a different design. If my adder is better in power, then that's a different design. Fundamentally, it is like this. And also, if you're exploring abroad, then there are like lot of Uh, I could say in foundries. Like for example, nowadays there are multi-die solutions. Like your whole CPU will not be on one die; it will be on multi-die to save power. So there
Mm-hmm.
you have a completely different kind of interfaces and data transmission between which dies, the interposers, etc. So lot of R&D opportunities available.
Mm-hmm. Yeah, and also you can try reducing, see if some operation like addition or subtraction or might be matrix multiplication is consuming some cycles like 100 cycles. So if somebody is able to optimize it and reduce the clock cycles consumption, so he can patent the design or publish paper or do some R&D on that. So in the VLSI there is a scope of that things. So in this case we can give a win for the VLSI. Yeah.
Yeah.
So next is our abroad opportunities like international opportunities in terms of embedded and VLSI. So what do you say, Rohit, about VLSI?
Yes, VLSI manufacturing is not in India yet, so it is more in abroad. So
Mm-hmm.
USA, Germany are major players, Europe.
Mm-hmm.
So there are a lot of opportunities abroad and
Mm-hmm.
also a lot of salary also.
Mm-hmm. Yeah, yeah. In VLSI, you have a lot of opportunity. Yeah, as you told, because there is no manufacturing unit in India as of now. So usually they work on mostly designing, verification, these things. In terms of embedded as well, compared to VLSI, it is a little less. So I think in this case we can give a win for the VLSI. So yeah, final thing which everybody is waiting till now is about salary. So in terms of salary, what do you say, Rohit?
Okay, yeah.
What is a beginner
In
level
India,
salary for a fresher? What is the
in,
salary and for experience
in
after
India,
five
right? In
years?
India.
Yeah.
Yes, it again depends. In private company, it is 12 LPA. Usually, sometimes, rarely it is 7. And
Mm-hmm.
in service, it is 3 to 5 LPA.
Mm-hmm.
One more thing, in service, you will have 2 3 years bond. Project, you
Mm-hmm.
will not have any bond in the beginning. And
Mm-hmm.
usually, in the starting years, the increments are very good. Usually, it's minimum 40 50%. Some
Mm-hmm.
companies even 100%.
Mm-hmm. Yeah. Yeah. So in embedded also the initial salary would start from 4.55 LPA for a fresher. So it go on till 10 or 20 LPA for at least 10. A 4 year experienced guy is getting at least 15 LPA in most of the companies which I have seen. It completely depends on the service based or product based company. So product based company they pay good, and even here in embedded also we do have bonds, and there is a fine amount. If you are breaking the bond you need to pay certain amount in order to break the bond. So at least 2 to 3 years bond you will have in embedded as well. But what I would say is compared to embedded, there is in VLSI there is a little bit higher salary compared to embedded systems. So in this case we could give a point for what do you say, VLSI. Yeah. So that's it. I think I've covered all the points. Yeah, and we'll make a comparison. I think in both of the cases there are 7 wins in embedded and 7 wins in VLSI. There is a win-win in both the case, but it completely depends on the domain. So which you want to get into, what is your interest. Uh, so no domain is good or bad, or what do you say, better than other thing. So both are at its own place. Both are having their own advantages and disadvantages. So choose your domain wisely. So what do you say, Rohit?
Yes, yes, that was perfectly correct. You have to think what you want to do
Mm-hmm.
because though both fields complex and opens up doors to very different things. So
Mm-hmm.
it depends on what you want to do and what you like to do. So in the long run, that is more important and will lead to everything you need.
Mm-hmm. Yeah. So there is one more interesting question I had. So if you want to shift your domain from embedded to VLSI, or maybe from VLSI to embedded after 1 or 2 year experience in different domains, how do you think in your domain is it possible? If somebody is worked in embedded for 2 years, you want to shift to VLSI, so should he start from the beginning, or will his experience add value?
It depends. It will add value in some cases. Like if it was embedded was more on hardware side,
Mm-hmm.
then it becomes easier. I would say if it was like core top level software side, like embedded C or in that way, then maybe it will get a bit difficult. But it is always you can switch, because I've seen people switched like from software engineer to VLSI like after 3 years of software engineer.
Mm-hmm. So in my domain, I have seen a lot of people from ISC and CSC guys. They are not getting web development projects and everything, so they learn C, C++, and they shift into embedded. So from Verilog guys, I have seen a few Verilog guys shifting into embedded also. They have some good knowledge in embedded as well. So yeah, shifting is possible. They can shift. Mm-hmm. Yeah, okay, sure. I think we have covered all the topics. So, see you next time. Bye bye. Thank you.
Yes, bye. It was nice.